And then I need you to click on modules. And realize mine looks a little bit different than yours. You're in the app, but it's pretty similar. Okay, on the general class info module is a link all the way at the bottom that says WebAssign PHA 1920. I need you to click on it. Everybody with me? Okay. It's going to say Launch External Tool. You're going to click on Launch External Tool. And mine, again, it's not going to look the same because you're just logging in. What you need to do on that screen is it will eventually, it'll take a while, but it'll eventually load. You get a white screen for a little while the first time especially. And you get to a screen that has two little red boxes. One says Sign In and one says Create Account. I'll wait for you to catch up. You're good. You're already in. Are you red boxes or it's still white? Red boxes. Okay, red box. Okay, click Create Account. Your information should automatically populate in those boxes. Do you see it? Yes? Okay, all you need to do is add your, obviously you're going to create birth. You do your birth year. No, you were born in 2019. Do your birth year. Go to my class. General class info. No, there. All the way on the bottom, the very bottom. Take that. Okay, and then you're going to create a password for yourself. Make it easy. Make it the same thing as your Google. I think it does need a capital letter so you can test it out, but I think it does. Oh, wait. Yeah, okay. So you switched up. Your birth year? You don't need that. Do your birth year. And then do your password. Click no on I want to receive information. You don't want one more email in your inbox, so those will be that 30,000 emails. Yeah.
If I automatically didn't have my information, that's fine.
It is, but it's weird. Just let it go back. Go back. Because it should link to, go ahead and click create account again. Oh, you're in the, you went to the web. Go from the app. Because it should automatically know who you are based on Canvas. Like it should, there you go. It should bring your information in. Okay, once you've done your birth year and your password, you need to check I have read and agreed to Cengage. I have read and agreed to Cengage, and then click create account. So all that it did was just like create an account using the information that you had in Canvas, okay? And this is your account now in WebAssign. So what you need to do is, you need to ignore the thing at the top that says this is a trial period, okay? You can X out on that box if you want to. And then underneath it should say My Assignments, all the way down at the bottom. It should say My Assignments, and you've got a list of assignments, okay? I'll hide some of them so that you don't feel overwhelmed, okay? But your homework's going to appear there. So what will happen is on Canvas, in the body of your Canvas assignment, it will say, go to WebAssign to 1. And it actually will have a little link that takes you right to the module, but you'll always have to go back there. I'll show you what one looks like. This is 1 too, so it's different. But it will say complete the homework through WebAssign. That WebAssign is the hyperlink to that module. It will bring you right to the module, but you're still going to always have to click on that WebAssign link. It will load, and then it will say submit a screenshot of the results. The picture must show your name on the top right, place at the bottom of a document with your work, and then submit the file to this assignment. So what you're going to do for practice right now is click on the one that says non-graded 1-1 warm-up. The assignment in WebAssign will be named the exact same way as the assignment in Canvas so that you know that they go together. So the date and the section. Now what you should see, there's a couple of questions depending on the actual assignment. You will get more questions, short questions, whatever it is. This is going to be you have to figure out your workflow, like what works best for you. Most people last year would screenshot those pictures and then pull them into Notability, work them out in Notability, and go back and answer them in WebAssign. If you want to open WebAssign from the web, now that you've created your account, you can. And then you can split screen, and you could be working left side WebAssign, right side Notability. You with me so far? Okay. Here's the thing. There are problems that don't require work, like plotting of a point. I don't need to see your work. You're submitting your answer on WebAssign. But then there's things like find the equation of a line, in which I know to look for work. You need to show work for those problems. You'll do that through Notability. So Notability is where you're doing all your work, but then you're going to go to WebAssign and you're going to answer the questions through WebAssign. At the end, it's going to give you a score, and the score appears like in a box in the top with little boxes with what you got right and what you got wrong. You are going to screenshot that for me, making sure I can see your name with your score, and then you're going to put that at the top of your assignment in Notability. Does that make sense? Yes? And then you are submitting the Notability document. So you're submitting two things, one on WebAssign, one on Notability. I can go in and check all of your WebAssigns, but it's so much easier to do the grades in Canvas so that I will operate from Canvas. Only if I have a question, like if I'm questioning the integrity of your assignment and you've like thought you were clever and like whited out somebody else's name and put your name there, I can go and see what you completed in WebAssign. Don't make me do that, okay? And again, the ones that don't require work, you don't need to show work. The ones that do require work, do, and I know the difference, okay? If you get a question wrong on WebAssign, you have 3 shots, you have 3 chances. Sometimes it's the format of how you typed your answer, okay? I am not going to dock you points if you have the work to back that wrong answer, okay? So sometimes the graphing gets like annoying. You can graph in Notability, okay? When you screenshot it in a box that has a graph, it will be marked wrong, but I will then go, okay, number 3 was marked wrong. I'm gonna look through your Notability document and find the work for number 3. If you have work for number 3, I ignore that it was wrong. You with me? An 80 to 100 with work automatically gets 100 in homework. So a score of 80 to 100 in WebAssign with work automatically gets 100, okay? Anything below an 80, if you are missing work, that's when you will see your grade go down for homework, just like regular. So there's a lot of reasons we started using WebAssign. One was it does individual problems for each of you, because let's face it, you cheat like hell, and you're not learning anything. Second thing is, it will allow you to have as many practice problems as you want. So if you get to one question that you know you're struggling on and you need extra practice, you can come back into WebAssign and say, create additional practice problems for me, and it'll create additional practice problems for you. The third thing is you're knowing feedback immediately. You're knowing if it's right or wrong, if you're on the right track immediately. And the fourth, and probably one of the most important things is, we have heard from alumni that they're going to college and they're taking math courses online and they are struggling with the online interface. So we're trying to get your feet wet in a way in which your teacher, me, still care about you and will help you get to know this interface. Ms. Meadows literally just got an email yesterday from a graduate that just said, I just went to my first day of school and people are freaking out because they're using WebAssign and I feel so comfortable with it. It's not, I don't have to worry about it. So it's definitely something that you'll see again, not necessarily WebAssign exactly, but you'll see some sort of online interface with math, okay? So questions so far? Yes?
So if you get less than 80 but you have work, will it?
I will still give you the 100. Yeah, like work within reason, not like you wrote out like the alphabet, right? Like so you have to fill space, but yes, even if you get it wrong, yes.
And also, so on the Notability, when we take a screenshot, do we submit it with like the work we wrote?
Yeah, I'll actually show you an example of what would get you 100.
Okay.
Yep, I'll show you an example. Yep.
Do they like expire or something? Because like say you're absent and then.
Okay, great question. So if you're absent and it's past the due date, it will say you're past the due date, you can no longer access this. There's a little thing that says request extension. You'll click on request extension. It sends me an email that says this person wants an extension on this assignment. If you are absent, I will grant you the extension. Does that make sense?
Yeah.
Okay. And I said it yesterday, but I want to reiterate that after 8 a.m. on the due date, it's going to show you the key. So once you're done with your homework, you're going to go back into WebAssign, you're going to click on show key, and then you can see the answers to the ones that you got wrong. Does that make sense? If you're like a person that works with a buddy on homework and you like, I don't care. You can learn from each other. It's very different than here's my homework, okay? But the types of problems will be the same. So the numbers might be different, but the types. So if you call a friend or you text a friend and you're like, how did you do this problem? And that person explains it to you, I'm good. You can learn how to do it that way, okay? It's like your little at-home tutor. Take advantage of it. But it shouldn't be like, here's your answer, because they're going to be different questions. Does that make sense? Okay. All right, so I'm going to show you an example of what an actual assignment should look like. All right, this is the R2 warm-up. So number 1 says to make a table of values and sketch the graph of the equation. I didn't give you a table of values this time, so you can choose what you want in there. I would advise that you pick something that has negatives, positives, maybe 0. So like -1, 0, and 1 would be probably your best bet. And then plug them in. So 1 minus -1 squared is 1 minus 1, which is 0. 1 minus 0 squared is 1 minus 0, which is 1. 1 minus 1 squared is 1 minus 1, which is 0. So I get 0, 1, 0. And then you want to plot your graph. So I'm going to plot -1, 0, 0, 1, and 1, 0. And I get that curve, which we know is eventually going to be a parabola. But for right now, the curve is fine. Questions on that one? Okay, 2 says find the x and y intercepts. So how do I find the x intercepts? Good. So I get 0 equals x squared minus 9. What's one way to solve that? Because there's more than one. Move the 9 over. So I could add the 9 to the other side. And then when I square root, the only thing I have to be really careful about is making sure to do what?
Plus or minus.
Plus or minus. Good. So don't forget about your even root property, which says this would be plus and minus 3. So you get 3, 0, and -3, 0. And then your y-intercept, you do what? What are we plugging 0 in for? X. So y equals 0 squared minus 9, and y equals -9. Again, remember that you want to give it to me in coordinate point format, like that. Questions on that one? Okay, then goes test for symmetry. So here we want to test x, y, and origin. So the x-axis symmetry test is to do what? Good. So -y equals x to the third plus 10x. Does that match my original? Nope. Is every term the exact opposite? Nope. The only one that's the opposite, right, is just y. So it is not symmetric to the x-axis. Do the same y-axis, except this time we're changing the x. So I get -x to the third minus 10x. It's not the same, and 2 of the 3 have changed, but not all of them, so this is still an O. And then the last one is your origin. This time I'm replacing both -y and -x. So I get -y equals -x to the third minus 10x. Not equal to the original, but what's true? They are the opposite signs, right, of my original. So it is yes to the origin. So no to the x, no to the y, but yes to the origin. Everybody still good? Yeah. Okay. 4 says write the equation of the circle. I give you the center and the solution. So we talked about this yesterday, that there's 2 ways to do this. What's one? One is plug them in, right? The center would be your h, your k. The solution is your x, your y. So this would be 1 minus a -1, which becomes plus 1 squared, plus y, which is 2, minus k, which is also 2, equals r squared. And I get 2 squared plus 0 squared equals r squared. So r squared is 4. If it doesn't ask for the radius, you don't have to square root it. If it asks for the radius, then obviously I would say that r is 2. But if it doesn't, which in this case it just says write the equation, that's what I need. So now when I write it again, I get x minus a -1, which becomes plus 1 squared, plus y minus 2 squared equals r squared, which is 4. What's the other option to finding the radius if I have the center and the solution?
You could use the distance formula.
Good. You could use the distance formula to find the distance from the center to the solution. You just got to remember that when you plug it back in, you've got to square it. That's all. But you can use either method. Questions? Okay. Go through the solutions to the homework. Okay. Again, I won't do this once we start WebAssign. WebAssign is your solutions, but since these weren't on WebAssign, here's the answers. Okay, so 8, I actually think I skipped some of these. So 8, A is yes and B is yes. 12, A is no and B is yes. 16, your T-chart should have looked like that. -2, -5/2, 0, -1, 1, -1/4, 4/3, 0, and 2, 1/2. And then your graph like that. 20, x and y intercepts. X-intercept is plus and minus 2 and 0. Y-intercept is 0, 16. 24, your graph should have looked something like this. It said find the x and y intercepts of the graph of the equation. So the y-intercept is 0, 8. The x-intercept is 8/3, 0. 28 was your absolute value. So x-intercept, -10, 0. Y-intercept, 0, -10. 32, x-intercept, -1, 0. Y-intercept, 0, 1, and 0, -1. 36, symmetry, there's y-axis symmetry, not x and not origin. 40, there's no x, no y, but there is origin. 44 asks you to use the symmetry to find the other half of this graph. So all you got to do is like duplicate it on the left side like that. Because if it's y-axis, it flips over. 48, intercepts are x-intercepts -2, 0, 0, 0. Y-intercept 0, 0. There is no symmetry, and your graph looks like that, or something like that. No, 48. Did I skip 48? Okay. 52. X-intercept is 1, 0. Y-intercept is 0, 1. There's no symmetry, and your graph should look something like that. Again, it doesn't have to look exactly like these because I didn't give you the points to plot. So you're kind of guessing what points to plot. 56, x-intercept -5, 0. Y-intercepts 0 and plus and minus √5, and it's x-axis symmetry. Graph was a parabola turned on its side. 70, there's your circle, center 0, radius at 5. Your equation is x squared plus y squared equals 25. 74, it should have been x minus 3 squared plus y plus 2 squared equals 25. And your graph should look like that. '78, center is 0, 0, radius is 4. And then your graph should look like that. And 82, center is 2, -3, radius is 4/3, and your graph should look like that. Questions on any of them? Okay, so let's get to lines and the planes. So again, still kind of in the review phase, but this is the first section in your actual book, okay? So this now corresponds with your textbook. We start with slope, how steep a line is. It's also change in y over change in x. The equation is y2 minus y1 over x2 minus x1. It's also referred to as rise over run. There's 4 types of slope. Positive increases as you move from left to right. Negative decreases as you move from left to right. No slope is vertical, okay, or undefined. And slope equals 0 is flat or horizontal. So if you like ever run on a treadmill, if you think about it, like the higher the incline, positive, the higher the slope it is to walk up. If some treadmills are like let you walk down like you're walking downhill, that would be a negative incline. If you could somehow manage to get your treadmill to go straight up and down, there'd be no grip for you to hold on to. There's no slope. And then at flat, it's at 0. These equations are your x equals a number without an x, and these equations are your y equals a number. Sorry, x equals a number for the first one without a y, and then y equals a number without an x for the second one. So vertical is x equals, horizontal is y equals. It looks like the opposite axis. There are 3 types of equations of lines. Slope intercept is the first one. Probably the one the most recognizable, which is y equals mx plus b, where m is your slope and b is your y-intercept. Then you get point slope, which is y minus y1 equals m times x minus x1. The point is the x1, the y1, and the slope is the m. In this equation, your x stays your x, your y stays your y, same as the first one. And then the last one is called standard form. This is one you're not going to plug into. You very rarely plug information into standard form. But what the directions might say is to give the equation in standard form at the end. And for this, they all have to be whole numbers. X must be positive. So the x and y are on the same side, the constants on the other. And they have to be whole numbers, meaning no fractions, no decimals. And the x has to be positive. The y can be negative, but the x has to be positive. All right, so this one just says find the slope of the line with the given information. The first one, they give you the 2 points. The second one, they're giving you the graph. So for the first one, this is where you want to use y2 minus y1 over x2 minus x1. It does not matter which ones you make the 1s and the 2s, as long as they're consistent within the parentheses. You can't have like an x1 with a y2. So now I'd get 7 minus 2 over negative 5 minus a negative 3. And I get 5 over negative 2. There's the slope. If you're feeling like this is a ridiculous thing to review, every year somebody gets the equation wrong on slope. They put the x's over the y's. Don't do that. Okay? Rise over run, y's over x's. For B, you can do the same thing. I can use the points that they give you, or you can physically count your rise and your run. So rise, if I start at the top and work my way down, that's 1, 2, 3, 4. That's a negative 4 because I went down 4. And then run 1, 2, 3, 4. That's a positive 4 because I went to the right 4. And I do rise over run, and then simplify, I get negative 1. You could also go the other way. I could go from the bottom point and work my way up. 1, 2, 3, 4. That's a positive 4. And then work my way left. 1, 2, 3, 4. That's my negative 4. It doesn't matter either way. You end up with the same answer. Both would give you negative 1. Still feeling pretty smart, right? Okay. Not to burst your bubble, but that's not going to be a quiz question. All right. Graphing a line using point and slope. So if I gave you an equation that had point and slope, or it actually has m equals 3 and b is 0, 4, then you're going to start at the y-intercept on the y-axis and then use the slope to find the next points. Okay, horizontal and vertical lines, this is what we talked about before with the slope. If it's a vertical line, then the equation is an x equals a number with no y. And if it's a horizontal line, then it's a y equals a number and there is no x. Because there's only one variable here, it's not like you can plug these things in and figure it out. You just got to know, okay? So if you think about a vertical line, let's just say, that passes through 1, 2, let's say it's passing through 3, the x is 3. No matter what point on that line, the x is always 3, right? The x never changes. The y changes, but the x never changes. That's why this is an x equals equation, okay? And then vice versa for a horizontal line. If this is 1, 2, 3, 4, let's say it's passing through 4, the y is always 4 on all of those. The x might change, but the y is always the same, so that would be 4. This was 3. That would be 4, okay? So if you're ever like doubting yourself or you're forgetting, you can always think about it that way. All right, so find the slope and the y-intercept and then graph it. And yes, we're going to baby step it. So I'm going to give it to you first in slope-intercept form. What's the slope of this equation? 2. What's the y-intercept? 0, -1. Okay, so b itself is -1. The y-intercept 0, -1. And then it says graph it. So I'm going to come over to my graph. All right, now we're going to graph it. So I'm going to go to my y-intercept, which is 0, -1. Plot a point, and then my slope is 2, so I'm going up 2 into the right 1, up 2 into the right 1, and I'm drawing my line. Oops. You could also go down 2 and left 1, because that would also give you a +1 as slope, depending on your space. All right, B, what is your slope? -3 or -3/1, and then your y-intercept?
0, 2.
Good. 0, 2. So now I'm going to start at 0, 2. I'm going to go down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1. Close enough. Okay. And then C is not in slope-intercept, right? So you can do two things. You could choose to just put it in a slope-intercept. I could solve for y. So I'd get 2y equals -3x plus 6, and then divide everything by 2. Don't forget to divide your b by 2, common mistake. And now my m is -3/2, and my y-intercept is 0, 3. So I'm going to go to 3. Slope is -3/2. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. Okay. The other option would have been the shortcut for slope in standard form is -a/b. So if I look at this equation, -3/2 would give me my slope. And then I could plug in a 0 for the x if I wanted to find the intercept. I would say most likely most people solve for slope-intercept and then figure it out from there. But you could do either one. Everybody's still good, right? Yeah? Okay. All right. Now we're going to find the equation of the line. So flip it. Last one I gave you the equation and got information. Now I'm going to give you information and get the equation. So the first one gives you a slope and a point, okay? You can do this 2 ways. My advice is if it gives you a slope and a point, plug it into point slope, which is y minus y1 equals m x minus x1. So the y stays the y. The y1, this is your x1, this is your y1. y1 is 7. The m is 2. The x stays as x. The x1 is a -1, so minus a -1 becomes +1. Distribute the 2, move the 7 by adding it, and I get my equation in slope-intercept form. Your other option, and I don't care which one you use whichever the one you're the most comfortable with, is to take this information, plug it into y equals mx plus b, solve for b, and then plug it back in. So in this case, this is the x, this is the y, this is still the m. 7 equals 2 times -1 plus b. 7 equals -2 plus b. B would equal 9. And then I'm going to take that and the slope and plug it back in. Y equals the slope, which is 2, x plus b, which is 9. Either way, you get the same answer. You do whichever one you're the most comfortable with. Okay, B, slope negative 3/4 passes through 3, negative 2. Yes, you're going to get fractions. Okay, fractions are your friend. You're not allowed to freak out. So I'm going to plug it in point slope. Y minus negative 2 becomes plus 2 equals negative 3/4 x minus 3. Distribute the negative 3/4. Subtract the 2. So I need that to have a least common. 2 is the same thing as 8/4. And I get y equals negative 3/4 x plus 1/4. So now C just gives you 2 points, right? I don't have like the point and the slope. So what do I have to do first? Find the slope. So I'm going to use the points to find the slope. y1 minus y2, no, y2 minus y1, sorry, over x2 minus a negative 8, which is 0. So I get 6/0. What's 6/0? Undefined. It's not zeros, right? It's undefined. What does it mean if the slope is undefined? It means it's a vertical line, which is a what kind of letter? X or Y? It's an X. Notice if you look at the points that were given to you in the beginning, the X was the same. The Y is different, but the X is the same. You can also catch it that way. If the X is the same, then it's an X equals. If the Y is the same, then it's a Y equals. And again, I would say almost every year somebody says that 6/0 is 0. If the 0 is in the bottom, it's undefined, right? You can ask Siri. She says something about Cookie Monster not having any friends and not having any cookies, okay? All right, last thing, and this is honestly like the thing that people screw this up so badly, I don't know how, okay? Parallel and perpendicular. So the relationship between two parallel lines is that they never intersect. So they have the same rise and they have the same run, which means they have the same slope. Perpendicular lines meet at a 90-degree angle, which means their slopes are the opposite reciprocals of each other. You have to flip the number and change the sign. Okay, so the first thing we're doing is just looking at these two equations or 2 points and determining if they're parallel or perpendicular. So if I look at A, okay, they're both in slope-intercept form. All I got to do is look at the M. One is 2 and one is negative 2. Are they the same? No. Are they opposite reciprocals? No, they're opposites but not reciprocals, which means this is a neither scenario. They are neither perpendicular nor parallel. And I go to B. Now look at your M, -1 or +1/3 and -3. So what's true about these lines? They're perpendicular, which you can either write out the whole word, perpendicular, or upside down T, same thing. C gives you the points. So what do you got to do first? Find the slope. So 9 minus a -1 becomes 9 plus 1. 5 minus 0. I get 10/5, which is 2. 1 minus 3 and 4 minus 0. -2/4, which is -1/2. What's the relationship here? Perpendicular, opposite reciprocals. For this up, this is what they screw up, okay? Write the equation of a line through the given point that is A, parallel, and B, perpendicular to the given line. The line that's given is 3x plus 4y equals 7, and it passes through -2/3 and 7/8. So what I need from this first line, this equation, is just its slope. That's it. I'm not taking anything else from it. I just need to know what the slope of that line is, okay? So again, you've got options. You can get it into slope-intercept form and then look at your M, or shortcut is -a/b. So -a/b, the a is what's in front of the x, so that's -3 over the b is what's in front of the y, that's 4. That's the slope of the line that's given to you. Now I am done with this line. No matter how many times I say it, don't use the 7. Don't use anything else from that line. That's all you need is the slope. You with me so far? Okay. Now I'm dealing with this slope and these points, and it's 2 questions. The first one is find that equation if it's parallel to the first line. So if it's parallel to the first line, what's my slope of the new line? -3/4. I don't change it. And then my point is negative 2/3 and 7/8. And I'm going to plug it in a point slope. So y minus 7/8 equals negative 3/4. X minus a negative 2/3 becomes plus 2/3. Got lots of fractions in here. Super fun. Y minus 7/8 equals negative 3/4 x minus this times this. The 2 goes into the 4 twice and the 3's cancel. So it's just 1/2. And then I got to add the 7/8. Change it so it has a like denominator. This would be 4/8. And I get y equals negative 3/4 x plus 3/8. Okay, then you've got then you got perpendicular. So again, the only thing I needed from that first equation was the slope. What's a slope of a line that's perpendicular to that? Positive 4/3. So take it and flip it. Now my slope is 4/3. Flip it, change the sign. But I'm still using the same point, negative 2/3 and 7/8. And I'm plugging it in again. Y minus 7/8 equals m. X minus a negative 2/3 becomes plus 2/3. Y minus 7/8. Distribute the 4/3. 4/3 x plus 8/9. Add the 7/8. This time when I add these together, I got to change both, right? So if the denominator's 72, then it'd be 64 over 72 plus 63 over 72. And I get y equals 4/3 x plus 127 over 72. Okay, and then we check to make sure it can be simplified, right? So 1 plus 2 plus 7 is 10. That's not divisible by 3. They're not both even, so I can leave it the way that it is, okay? I said it just before you guys got back in here, but this is the one that people make the biggest mistake on, okay? We talked a lot about slope and lines. That was it. But I don't know, no matter how many times I say it, like, they all go back to the first equation and grab the y-intercept. The only thing you're getting back from that first is the slope, okay? And then you're done. Then you use the point that's given to you. Mm-hmm.